And what is alkyl halide? Alkyl halides are the alkyl compounds in which the hydrogen is replaced by halogen. Actually, this CX bond, the halogen carbon bond, it is polar in nature due to the difference in the electronegativity of carbon and this halogen. So, actually this CX bond exists as polar in nature. C having a partial positive charge and this halogen is having a partial negative charge. And this nucleophilic substitution reaction takes place in this alkyl halides. This is in general reaction. This in case of alkyl halides, nucleophile will react with this alkyl halide, and this halogen is replaced by this nucleophile, and the substitution product is produced. This is the actual reaction. Actually, there are two types of reactions. That is SN1 and SN2. SN1 is a unimolecular nucleophilic substitution reaction, and in case of SN2, it is a bimolecular reaction. And why this unimolecular? Why it is bimolecular? In case of bimolecular SN2 reaction, the reaction rate is directly proportional to the molar concentration of alkyl halide as well as the nucleophile, so that it is known as a bimolecular nucleophilic substitution reaction. And the reaction mechanism takes place in a single step. This is the step. Let me explain the mechanism. Okay, next is the mechanism for SN2 reaction. This is the reaction I have written here. This is the substrate, the primary alkyl halide, and this is the nucleophile. Nucleophiles are electron negative compounds or the functional groups. They are electron rich in nature, and so that they can easily attach to an electron deficient cell. This is the electron deficient center in this substrate. Due to this electron negativity difference between this halogen and this carbon will exist as a partial positive charge, and this halogen will exist as partial negative charge. So a nucleophile can easily attack this carbon. And the next step, this is the activated complex. By reacting this nucleophile with the substrate, an activated complex, the intermediate is produced here. And this is the intermediate, is also known as the activated complex. In this stage, this carbon is directly attached to or covalently bonded to 3 hydrogens, and the carbon is partially attached to this halogen and to this nucleophile. Here we can see that this is not a fully bonded bond, it is a partially bonded only, because this carbon halogen bond started breaking, and this halogen, this carbon nucleophile bond started making. This bond breaking and bond making occurs simultaneously. This is the mechanism. And after that, this bond is completely broken and this bond is completely made. And this is the final product. And here you can see that the configuration of substrate and the final product, they are just opposite. So that it is known as Walden inversion. The change in the configuration of substrate and the product is known as the Walden inversion. Okay. Next is the order of reactivity. Actually, this mechanism is a back attack reaction. So that if it is a primary alkyl halide, then the reaction will progress more readily. So if it is a methyl, then it will react more readily. And after that only the primary. So the order of reactivity is methyl alkyl halide will react more readily than that of primary, and distillate more reactive than secondary, and secondary is more reactive than of that of tertiary. This is the order of reactivity of alkyl halide towards SN2 reaction. And the next one, the second type of reaction, that is the SN1 reaction. This is a unimolecular reaction, and here it involves 2 steps. First one is the formation of carbocation intermediate, and the second step is the reaction of nucleophile to this carbocation intermediate. This is the addition reaction. So here the total reaction is depending upon the concentration of alkyl halide only. So this is the primary step, or this is the major step. Here this bond breaking, here actually this CX bond breaking and it will form a carbocation. This halogen will move with its pair of electrons and leave a positive charge on this carbon, and we will get a carbocation intermediate. And this carbocation intermediate is reacting with this nucleophile. The nucleophile is electron rich, so that it can easily attack this electron deficient carbocation, this carbon center, and it will directly form a new bond. Here the substrate and this product both are having the same configuration. This is the difference between the SN2 and SN1 reactions. There are two types of nucleophilic substitution reactions, that is SN1 and SN2 reactions. First one is SN2. SN2 means it is a bimolecular reaction. The rate of reaction is directly proportional to, or that is depending upon the concentration of alkyl halide as well as the nucleophile, and it is occurring in a single step, and it is a backside attack, and the van der Waals inversion is also involved in this. And the order of reaction, how it is reacting. This methyl halide is more reactive, then after that primary, then secondary, and then tertiary. This is the order of reactivity. But in case of this SN2 reaction, SN1 reaction, it's a unimolecular reaction. That is, the reaction is the rate of reaction is proportional to the concentration of alkyl halide only, because it is a two-step reaction, and this first step is considered as the primary step, and this is the primary step, or this is the considered as the rate limiting step. Here the concentration of alkyl halide is determining the rate of this whole reaction. So this is the first step, and the second step is the reaction of carbocation with the nucleophile and the corresponding product. The nucleophilic substitution product is produced. This is the order of reactivity. Why this tertiary is more reactive? Because a more stable carbocation is produced only in case of this primary alkyl halide. Because a tertiary carbocation is more stable than that of a primary or a methyl carbocation. So this is the order of reactivity. Tertiary is more reactive. After that, secondary, then the primary, and least is the methyl, or it may not occur. And hope the portion is clear for you.